Alcohols are compounds containing an OH functional group. They can be named either as simple alcohols, which would be used for an alkyl group that doesn't have other functional groups in it or doesn't have complex branching. If things get more complicated, then you have to go to the IUPAC system. IUPAC will work for everything. So these examples in front of you here are simple alcohols. And as such, we're going to be naming them as alkyl alcohols. In other words, you put the alkyl group first, and then a space, and then the word alcohol. So the first one that we're looking at, you can see that we have right there an ethyl group, and so we're going to call that ethyl alcohol. Pretty straightforward. So ethyl alcohol. This next one here, you can see that we have an isopropyl group. So guess what? As you would expect, isopropyl alcohol. All right, so the last example that we have, we are looking at the name that escapes about 3/4 of the people all the time, including me, a sec-butyl group. And so, as you would expect, no surprises here, sec-butyl alcohol. All right, pretty straightforward, and you can also pretty much guarantee you won't be seeing these on the test. So then we get into alcohols that are more complicated. Pretty clearly, just looking at this example, you're not going to be able to name this as a simple alcohol. The alkyl groups are too long, there's some complex branching coming off of it that does not fall into our common nomenclature, and so we're going to have to do something different. So, under the IUPAC rules, the first thing that you do is find the longest carbon chain that has the carbon in it that has the OH group. So in other words, you have got to find the longest carbon chain that contains that OH group. Then you're going to have to name the parent, and that's just based on the number of carbons. So looking at this particular molecule, I see that my longest chain is going to be, let's see if I can successfully circle it, there we go, right there. And that contains the carbon that has the OH group. You can see it right there. Okay, so now as far as the number of carbons go, I think that it is 8. Let's check. 1, 2, 3, 4, 5, 6, 7, 8. It's 8. And as a result, the parent will be based on octane, but like IUPAC says, we're going to be dropping that E and adding an OL. Okay, so that is the first step in the nomenclature. Now, what we need to do, of course, is, you can see our longest chain there in red, is we're going to have to number it, because just saying octanol does not tell you where in that 8-carbon chain the OH is. So in order to number it, we're going to try to give the alcohol the smallest number. So we want to start at the end that the carbon bearing the OH has the smallest number. Now this particular one is fairly obvious, and what we're going to do, let's expand it out a little bit, is we will start from the top and we'll go 1, 2, 3, 4, 5, 6, 7, and then 8. And let's go ahead and shrink it down so we can see our rules. Then we're going to do pretty much what's consistent. We're going to name all the substituents and give their numbers, list them in alphabetical order. That's all standard stuff. So this one, the only thing we have to worry about is that propyl group that is at number 3 right there. So I think we are ready to go. This will be 3-propyl, and then it's 8 carbons, so octan. It's octanol, but I have to tell you where the OH is, so it's octan 2-ol. It is very straightforward nomenclature. Okay, now as far as alcohols that have other functional groups in them, at this point in time, we are only going to be worried about double and triple bonds. When you get into 421, we will have alcohols with ketones in them, and alcohols with aldehydes, and alcohols with carboxylic acids. But for now, we are just going to be worried about the functional groups that we've been studying. So we're going to limit ourselves to alcohols, double and triple bonds. So, in terms of the rules, we're going to find the longest chain that contains as many of the functional groups as we can get into it. So in other words, we want the longest chain that contains both carbons of the alkene or the alkyne and the carbon of the alcohol. You want to try to get as many functional groups as you can. We're going to, as usual, drop the final E from the alkene or the alkyne name, and we're going to add OL. So it's very similar to what we've been doing. We're going to have our parent, and then we're going to drop the E and add OL. So let's go ahead and let's do this first example. Taking a look at this, the parent is obvious. There's one chain. So what we're going to do is let's go ahead and figure out how many carbons there are. We have 1, 2, 3, 4, 5. So the actual name is going to be based on pentane. But it's an alkene, so it's actually going to be a pentene parent, because that alkene is actually within that chain. So it's a pentene parent. And what, according to the rules, what I'll be doing is dropping the E and adding an OL. Now, this name has a little bit of a problem. So where this parent is, let's just put this in here. Penteneol. I've got a problem though, because if I were to tell you this, you would not know where the alkene is, so I need a number there, nor would you know where the OH group is, so I'm going to have to put a number there. So I'm not quite done, but it's a start. I've at least got the parent. Okay? Going into this next one, let's take a look at how many carbons are in its parent chain. I have, starting at the CH3, 1, 2, 3, 4. So that is going to be a butene, and then we're going to drop that E and put an OL. It's a butenol parent. Again, I need to number the chain so I can give numbers to the alkene and the alcohol. So I'm going to have to put numbers where those arrows are. That brings us to number 2. Number the longest carbon chain starting at the end nearest the OH group. So that has to do with the prioritization of these functional groups. Alcohols have priority over alkenes. They're higher up, and so therefore they get the smaller number. So let's take a look at our first one. We have, and let's expand in right here. We're going to start at the end nearest the alcohol group, but the first one's pretty straightforward. It gets a number 1, and then 2, and then 3, 4, 5. Moving over to the second one, I will be starting at this end here, which will be 1. The OH carbon gets a 2. Squeeze in that 3, and there's a 4. Okay. Let's get things centered. Take a look. Alright, I think we're ready to move on. And now, we're going to have to designate where these functional groups are, like we talked about with the arrows. So I know where, if I were drawing this, where to put the double bond, where to put the OH. What you're going to do is place the number for the position of the OH group, which in our first example was number 1, before the OL ending, which is very consistent with what we did when we did enines, for example. There are 2 ways to do it, and as far as like the double bonds go, we can put the number before the name, or we can put the number with the ene, or the ine, which is what I prefer. Let's take a look at both systems. As far as the parent goes, under the old system, we are going to, this was a pent, so we would say under the old system, it's a pentene. So I'm going to go pent, ene, and then 1 all. And to indicate where the double bond is, I will put a 2 out front. That's the old system. The number for the multiple bond is in front of the name, and then the alcohol number goes with the OL. The new system is a little more consistent with everything we've done, and I think a little more logical, where you put the number next to the little suffix that indicates what that functional group is. So it'd be pent, 2, ene, 1, all. One thing we should point out too, notice that we dropped the final ending of ene, which the position I'm talking about is right here, the final ene ending. That's because over here we have a vowel. Okay, so we're being very consistent with what we taught you with alkenes. All right, this other one, the alcohol was at number 2, the alkene was at number 3, and it's based on butene. So the old system, I'm going to put the alkene number in front of the parent name. So this would be 3 butene, and then 2 all. New system, but dash 3 ene 2 all. Okay, in this one we also have a chloro group that is on the molecule, so we actually have to do a real name right now. The chloro group's at number 4, so pretty straightforward. We're going to do 4-chloro, and then but, no space, but 3 ene 2 all. Okay, so those names are almost complete. We're missing one thing, and it's the thing that always costs everybody a half a point on the test, and that is E or Z nomenclature. So, on this first one, up here, we have the groups coming out opposite sides. We could say trans here and get away with it, but let's just be consistent and we will say E. Now, we could squeeze it in next to the 2, right there, or alternately, you could put it out front in parentheses. Don't do both. Okay, if you put it out front in parentheses, a little dash goes there. So you do either out front or by the 2. Either way is acceptable, but don't do both. On this next one, it is going to be a Z, and so I am just going to put it out front since I didn't leave myself a whole lot of room. I'll go there. I don't have to put a number with it in either of these cases because there is only one double bond. Okay. All right. So here we go. OH as a substituent. You're going to run into functional groups, not in Chem 420, but in 421, where in the molecule is a higher priority functional group, like a carboxylic acid or something like that. So when you're naming these, the parent is actually the carboxylic acid. What that means for the alcohol is it becomes a substituent. And as such, it's going to be treated like a chloro group would be, or a bromo, or a methyl, or something like that. And we're just going to give it a number and the name hydroxy. So it is called a hydroxy substituent. So in this particular case, it's at number 3, 3-hydroxybutanoic acid. You won't be able to name carboxylic acids until later in 421, but you're going to run into this a lot, so just remember it's hydroxy. Now, a place where you could run into using OH as a substituent is when you have a parent that is an alcohol, and then a substituent off of that parent right here that also contains an alcohol. Now, both of those alcohols cannot be the parent. One's the parent, one's the substituent. So the parent's going to be the ring, and the substituent's going to be this ethyl group here with an OH on it. That's a hydroxy. So the point of attachment for that ethyl group we'll call number 1. The second carbon is number 2. So at number 2 is a hydroxy. Now, we have to name and number our ring. So on the parent, which is the ring, the OH carbon's number 1, that's 2, that's 3. Now we're ready to go. At number 3, we have a complex substituent. It is going to be 2-hydroxy ethyl, and then it's a cyclo pent tan all. I don't need the number 1 because by definition on a ring we are starting at carbon number 1. That's where the OH is. Now as far as diols, triols, etc., that is where you have obviously 2 alcohols or 3 alcohols in the molecule. We're going to be naming them just like regular alcohols, except for if, say for example, you have a diol. We're going to change the ending to diol. Because there is a D in the ending, it's not starting with OL, it's starting with a D, we are going to retain the final E in the parent name. Okay, pretty standard. And we also, since we have 2 alcohols, we're going to have to use 2 numbers to show where they are. So, let's go ahead and tackle this one. It is 3 carbons long. 1, 2, 3. And it's going to be propane. So it's propane, and we're going to keep that E. Alcohols are at numbers 1 and 2. So 1, 2 diol, just like that. If there were 3, you'd have 3 numbers, and it'd be triol, and you still would keep the E. If there were any substituents, they would be out front with their own numbers listed alphabetically, like usual. Okay, naming phenols. Phenol, by definition, is this molecule right there. And when you're going to be naming a phenol, that is the parent. And any other groups on there are going to be substituents. So the carbon that will be carbon number 1 is the carbon where the OH is attached. So phenols are actually pretty easy to name. The only thing that we need to talk about is how to name benzenes. We're going to be using these prefixes, potentially, ortho, meta, and para. And most people probably have been introduced to those, but let's just do a really quick review. If you have a benzene ring, and let's just draw a phenol, since that's what we're talking about, the ortho position is the position that is right next to your parent functional group. Meta to that OH is removed by 1 carbon. Para is the position exactly opposite. Now, organic chemists are pretty lazy. Sometimes ortho, you may see an O used. Meta, we drop down to an M. Para, just a plain old P. Okay, you could also use numbers. Either one of those would be acceptable. So in this particular example down below, I have an ethyl group. The ethyl group is in the meta position. So you may see meta ethyl phenol, or if you want to use numbers, it is, there's carbon 1, and let's go ahead and highlight it so you can see 1, 2, 3. You could also call it 3-ethyl phenol. Now thiols are compounds we're not going to spend a whole lot of time on, but we at least want to teach you how to name them. They're very, very similar to alcohols. Sulfur's 1 below oxygen in the periodic table. They're going to be named just like alcohols. The ending is just going to change. The ending for a thiol is going to be, surprise, thiol. Now because it starts with a T, we are going to be retaining the final E of that alkane parent. Okay? And just a particular note, if a thiol happens to be a substituent, you see the word mercapto used, that's an SH substituent. Okay, so let's go ahead and let's number and name this guy. Finding the parent, It's the one, we'll just go straight across. So there's 1, 2, 3, 4, 5. And so the sulfur, that thiol group, is at number 2. And we have methyls at 3 and 4. So this will be 3,4-dimethyl. And then it's going to be pentane, thiol. And I forgot to put the number. Let's back up real fast and let's put that number, pentane 2-thiol. Without that 2 there, you would not know where to put that SH group. Alright, and now we're ready for a few examples. Okay, so this one, let's go ahead and let's highlight the parent. So we'll go along, and the first one's pretty straightforward. I don't think I want to highlight it in black, though. Let's skip that. Let's highlight it in green. There we go. So there's the parent. Now we have to figure out some numbering, and in order to do that, let's go ahead and take a look from, I don't know, let's go from the left first. 1, 2, 3, 4, 5. Going from the left, it's number 5. 1, 2, 3, 4, 5. Going from the right is number 5. Okay, so now we have some choices. The next thing is going to be dictating substituents. So if we go in from the left again, 1, 2, there's 1 at number 2. 1, 2, there's 1 at number 2. So we keep going in. 1, 2, 3, 4. So we have a 2 and a 4 coming in from the left here. 1, 2, 3, a 2 and a 3 coming in this way. So we are going to be headed in from the right. So let's go ahead and 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And bromine's going to come first in the list, so let's do 2-bromo, 6-chloro. I have 2 methyl groups at 3 and 8, so we'll do 3,8-dimethyl. Now it's 9 carbons, so we'll go, it's nonane. So nonane, but remember we drop that E ending. Let's just erase it. And we put 5-all. Alright. Now this next one, the parent chain is going to be, and let's highlight it again, get a slightly thicker pen. It's going to be right here. Okay, that's the longest one. Yep, that looks good. Now I have a complex, well, somewhat complex substituent down at the other position. So let's go ahead and figure out what it is. It is going to be an ethyl group. You can see right there the 2 carbons. And there's a chlorine at number 1 on the ethyl group. So we got that nailed out. Let's go ahead and number the thing. 1, 2, 3, 4, 5, 6, 7, 8. So I wanted to give the alcohol the smallest number. So I gave it number 3. So at number 5, I have a 1-chloroethyl. Number 7 is a methyl. And then it's an octan 3-all. Alright, moving on. Here we have a phenol. Okay, so phenol is going to be number 1. And then we want to go around the ring such that we give the substituents the smallest possible numbers. So we're going to head around to the left or counterclockwise. That gives our methyl 2, 3, 4. And there's 5 and 6 we really don't care about. There they are. So I have a methyl at 2 and an isopropyl at 4. So this, I can't use ortho meta para here because I have 2 substituents. And you can't use ortho this, para that. Once you have more than one substituent, you have to use actual numbers. So I'm going to put 4 isopropyl, 2 methyl, and the ending phenol. Alright, pretty straightforward. Oh, now we have a thiol. The longest chain, oh, this one's got a little bit of a trick in it, so let's go ahead and let's highlight that longest chain. Here, 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 here. So tempting to go straight across. Everyone wants to do it, but don't. Make sure you pay attention. It actually curves up. That's a common teacher trick that we will use on you guys to try to trick you. Okay, now in terms of numbering this guy, the sulfur's closer to the left-hand end, so we're going to go from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure I did that right. It looks good. Okay, I have a lot of methyls. The ethyl is going to go first, so let's do it first. 6 ethyl. And then all these methyls. There's one at 5, one at 7, one at 8. So we'll have 5, 7, 8. Trimethyl. And then it's 10, so decane. Now we're going to keep the E ending because the next thing that comes is 4-thiol. That E ending is kept because of that thiol starting with a T. It's not a vowel, so we keep the E. It's one of those nice little IUPAC rules you have to remember. Okay. Now this next example looks a little bit intimidating, but let's just go ahead and identify the parent. The parent is going to be the ring that I'm circling in green. That ring is a diol. So we have a diol parent. That means that our substituent, and let's circle it in red, is that thing right there. So it is 3 carbons long. On the 3rd carbon is an OH group. The OH on the substituent thing, this 3-carbon chain, is now also a substituent. It is going to get the name hydroxy. So we're going to be calling this guy hydroxy. The diols, which are here and here, they're going to actually be part of the parent name. So they're going to get numbers, they're going to still be alcohols, and like that. So let's go ahead and let's number this thing first. We want to give the alcohols in the parent the lowest possible numbers. No matter which way I go, they're going to be 1, 2, 3, or 1, 2, 3. So they're going to get a 1 and a 3 regardless. So what's going to dictate which way I go is going to be giving the substituent the smallest number. So if I start at the left, 1, 2, 3, 4, the substituent gets a 4. If I start here at the right, 1, 2, 3, 4, 5, 6, I don't want to give the substituent a 6. So we are going to be going 1, 2, 3, 4. Alright, so at number 4, let's put it down and do it first. At number 4, there is a hydroxy group at carbon 3 on that substituent. There's 1, 2, 3. So we're going to say 3-hydroxy, and it's a propyl group because of the 3 carbons. So at number 4 we have 3-hydroxypropyl, and I put hydroxyl. Let's just fix that right now. We don't need any of that. So use the handy eraser. There we go. 3-hydroxypropyl. And now it's a cyclohexane parent. We're going to keep the E ending here because the next thing in the line further out is going to be diol, and so that starts with a D. So cyclohexane dash 1, 3 diol. And remember that E we kept because of that right there. Okay. Oh, right, the next one, now we're mixing two functional groups in there. We want the longest chain that contains both of them. And so let's go ahead and let's identify that parent by highlighting it. There it is. And now we can go ahead and probably number things. Now in terms of numbering, we have to decide if this molecule is an alcohol or an alkene. That's going to dictate the numbering. If it's an alkene, I want to start numbering from the alkene side. If it's an alcohol, I start numbering to give the alcohol the smallest number. Alcohols have priority over alkenes. So we are going to number with that OH having the priority and thus the smallest number. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. The alkene gets whatever number it gets. I have isopropyl groups at 5 and 6, so we will go 5, 6, diisopropyl, and then it is going to be, I'm going to do the new style, oct, it's an octene, so it's oct and 6 ene 3 all. We are almost done, but we've forgotten one thing, and that is E or Z. So let's go ahead and let's figure it out. Now, I think we need to expand this to try to figure out E or Z. So there it is, a little bit larger. Now, when we do E or Z, remember we have to figure out which groups are on the same side. I'm going to use red to prioritize the groups. Here's priority number 1 on the simpler side, right there. The H obviously is number 2. Now going to the side right here, the other side of the alkene, let's figure out what we're looking at. I'm going to go to the top first. So I go to the top, I hit a C. I go to the bottom, I hit a C. At the top, I go to 1 C and 2 C's. At the bottom, I go to 2 C's. So far I'm a tie, but then at the top, the C goes to 2 C's, and the other C goes to the alcohol stuff. Down here at the bottom, my C's end. So here at the top, I went to 2 C's, and they went on. Here at the bottom, I went to 2 C's, and they stopped. So my priority is going to be there, the top one. So looking at that double bond, my two number 1 priorities are on opposite sides, and so let's squeeze this back down. I am going to have an E double bond, and I'm just going to stick it, I'm going to put it with the number because that's where I like it. Squeeze it in right there. There it is. 6E, ene 3 all. Alright, our last example. Okay, this is the mother of all examples. Here we go. Taking again our parent group, we want to get the longest chain with the most functional groups we can get. So we are going to be going in through right here. This is an alkyne and a diol, so it has got a lot of stuff going on with it. Let's go ahead, and maybe the simplest thing to do is tackle the functional groups that are substituents. I have a 1, 2, 3 a propyl, and I have a 1, 2, 3, 4 a butyl. So I've got a propyl and a butyl. Now in terms of numbering, remember the OH has priority and it gets the smaller numbers. So when we're numbering it, we are going to go 1, 2, 3, 4, 5, 6, 7. Alright, make sure we got that right or nothing works. Yep, looks good. Okay, so I think we're ready to name this thing. Butyl, propyl, butyl's going to come first. So we have 4 butyl, 5 propyl, and then here we go. It is going to be, it's a heptyne, and then the diol. So we're going to go heptyne. The ine starts at 6, so 6 -ine. And then we're going to keep this E ending because the next thing's diol. Starts with a consonant. So we go dash, 1, 3, diol. Pretty big name. Okay, so that's alcohol nomenclature.